In this lesson, we're going to look at more applications with logs and exponential functions, talking about the compound interest and interest compounded continuously. And now that we know how to solve log equations, now we're going to end up being able to solve for how long it will take to reach a certain amount of money or what the rate would have to be instead of being able to just find the total value after a certain number of years. So we look at this first question. It says, how long does it take for $5,000 to double if it's deposited in an account that yields 5%? So it should look like that. 5% interest compounded once a year. So if you remember back at the beginning of this unit, we talked about the compound interest formula, and it looks like this. So A equals the principal times 1 plus r over n raised to the nt, where r is the rate, n is the number of times compounded, and t is the time that we're talking about. So in this case, we're looking at how long it's going to take. So we're trying to find t. How long does it take means find t. And we're trying to double $5,000. So that tells me that A has to equal $10,000 because I'm trying to double it. So my total amount has to equal 10,000. So I'm going to go ahead and plug in 10,000. My principal is still the original amount, which is 5,000. And 1 plus the rate, if the rate's 5%, as a decimal, it's going to be 0.05, moving that decimal over 2 places to the left. So we always put the rate in as a decimal. N is number of times compounded, so since it says compounded once a year, that tells me that N equals 1. So we go ahead and plug in 1 for that, and then T I'm just going to keep. So now we go ahead and we can simplify this and solve it for T. So I have in the inside here, 1 plus 0.05 over 1 is just going to be 1.05. And this is just going to be T. So now we have an exponential equation that we're trying to solve for t. We're trying to find the exponent. So just like all of the ones we did in the last lesson, we're going to go ahead and divide everything and isolate that base. So I divide everything by 5,000. I get 2 equals 1.05 to the t. So you're asking yourself, what do I have to raise 1.5 to 1.05 to get 2? So it's not something that's going to come out to be a nice number. So this is where logs come into play. Log will tell, if we take the log of both sides, it'll allow us to find t. So we take the log of both sides, and then as soon as you take the log of both sides, remember this t can come down as a coefficient. So it's log of 2 equals t times log of 1.05. So to solve for t, we're going to divide both sides by log of 1.05. And then you would put that into your calculator and you get t equals, so these cancel, so t equals log of 2 divided by log of 1.05, which comes out to be like 14.20669908, something like that. So what that tells me is about 14.2 years. So pretty much a little bit more than 14 years is what it's going to take for this money to double. So I'm just going to answer that as it takes a little longer than 14 years. So not quite 15 years, it'll be shorter because it's 14.2. So a couple months into that 14th year is when this money is going to double. And you can't say just 14 years because it won't happen at 14 years. It's not going to happen until 14.2 years. So within a couple months of that 14th year. So then example 2 here, same idea. So if we start with $1,000 in an account and it's going to double after 12 years, we want to know what interest rate does this account have to have if we're compounding the interest continuously. So remember, whenever it's compounded continuously, that's our PERT formula. So A equals P times E to the RT. And again, we're trying to double the money. So since we're trying to double the money, A is $2,000 since we're starting with 1,000. So $2,000 in for A. The principal is the amount that you start with, which is 1,000. E just stays. That's the growth rate. Um, and then R is the interest rate. So that's what we're trying to find. T is the number of years, which is 12. So now we solve this for R. So you can see that it's going to be an exponential equation again. So this is 2000 equals 1000 E if we multiply these to the 12R. So divide both sides by 1000. We got to get that base by itself. So we have 2000 divided by 1000 is going to give me 2. So those cancel, E to the 12R. And now we have an exponential equation with base E. So instead of taking log of both sides, remember it's convenient to take ln of both sides. If you really wanted to, you could take log of both sides, but by using ln of E is equal to 1, so it helps it make it easier because it becomes 1, ln of E. So I have ln of 2 equals, I can bring this exponent down, remember. So 12r times ln of E. ln of E is just 1, so we can forget about that. So I end up with ln of 2 equals 12r. And we have to get r by itself, so divide both sides by 12. So we end up with r equaling 0.057762265. So that's the rate that goes into the formula. So if we're talking about the percent, we have to multiply this by 100, move the decimal 2 places to the right. So we're looking at an interest rate of about 5.8. So if you imagine moving this decimal place over, it's about 6%, but I'm going to be a little more accurate and say 5.8 because the 7 would bump up. So the interest rate would be about 5.8%. So in order to get that money to double, you got to have an interest rate of 5.8%. And then let's look at the very last one here. So on the last page, we have a scenario where we're given a formula this time. So it's talking about the population of a small city, and the city council assumes that the population size T years later can be estimated by this equation, by this exponential growth. So P equals 32,000. So let me just write that down. 32,000 times E to the 0.05 T. So we want to approximate when will the city have the population of 50,000. So that's going to be P. This is what P has to equal. So we can go ahead and plug in. So 50,000 in for P equals 32,000 times E to the 0.05 T. And we just solve it. We just have to get T by itself. So first thing is to divide both sides by 32,000. And when you do this, you're going to get a decimal. So what I'm going to do is leave it as a fraction. The fraction that we have here in simplest form is going to be 25 over 16. If you divide those, I don't want to do a decimal because I don't want to round to the very end. So I'm going to leave it like this. Worst case scenario, you leave it as 50,000 over 32,000. I didn't want to deal with big numbers, so I just reduced it. Equals E to the 0.05t. Again, we have an E, so that means ln of both sides instead of log. So ln of 25 over 16 equals, bring this out in front, 0.05t of ln of E. So remember, this comes out in front. That goes to 1, ln of E. So now we have ln 25 over 16 equals 0.05t. Divide both sides by 0.05 to get t by itself. So you would just put this into a calculator. For t, we get about 8.925742053. So that tells me after 9 years, because it's going to take about 8.9 years, so almost 9 years. So we might as well just say after 9 years this will happen. So the population will grow to that amount after 9 years, or 8 years and almost 9 years, 8.9 years. So I'm just going to round up and say 9 years for that.